So now we are ready for the next talk that will be given by Los Alamos National Laboratories. So what they are interested in and they will show us is how to use emerging augmented reality headsets for, as a promising solution to perform the collecting of high-resolution 3D structural information in an on-the-fly manner, and they will demonstrate their current work so far. So, podium is yours.
Hello.
All right, good afternoon, everyone. My name is David Mascareñas from Los Alamos National Lab. I'm here with Fernando Moreau from University of New Mexico and Ben Chesborough from New Mexico Tech. Today we're going to tell you a little bit about augmented reality, these emerging technologies that we believe could be used to enable smart infrastructure. We believe these can be used to do much higher quality structural inspections, and we think it can also enable some interesting capabilities for when you're doing structural inspections, like in ropes and these sorts of things where you need access to your hands. And so this is an augmented reality headset. These things, they are basically, their main idea is that they're able to project holograms onto the real world. There's also a number of sensors built in them, depth cameras, irregular cameras, and these sorts of things. At Los Alamos, the main interest we have is to actually enable smart infrastructure, in the sense that we have nuclear facilities that are highly regulated. They have a lot of dangerous materials inside of them, and so people that are owners of those facilities are interested in giving users information about the cans materials in those facilities, but also giving them safety information about that. So I'm going to start off by showing you, this is just kind of a demo. If you look up to the screen, you should be able to see, this is kind of a virtual canister. So this would be an example of a nuclear material canister. What our customers are interested in is the ability to know what's inside of that canister. Now, I'm showing you a virtual canister. We can also track canisters and know what's inside of them. So what you're seeing now is the safety information associated with the nuclear materials here. We can associate, so for us, it's interesting to know, it's important to document what's packed inside these canisters. So this is just showing an example of taking a video and having the ability for the technician to bring up that video of what was packed inside the canister right away. And you're actually able to, these devices are able to do speech to text, so you could actually save documentation about all these different fields as you're working with the canister. Now, let's see if this works. Summon Wizard. Summon Wizard. Okay, so we can actually add a second nuclear canister. So we're concerned with nuclear criticality safety, so your canisters can't get too close together, but when they do, this is your blue flash of criticality, so that indicates that you had kind of a safety violation. And so you can see here it's bringing up information that tells you what to do in the case of that safety violation. So you know, okay, this is what we need to do to fix that. So I'm going to hand this over to Fernando, and he's going to tell you about visualizing multiple types of sensor data.
Thank you, David. Imagine I'm looking in the structure and inspector. I need to climb on a very vertical surface. I need to bring my data collection. So what I'm going to do is look at the structure here on the steel plate, and I have an area that I already have data about some Barkhofen test. So I can open it here on my menu. I'm climbing, I'm rappelling, and I open the inspector, David Mascareñas from Los Alamos, where they did this inspection. I can overlay on my surface, but I can hide it and look again on my material and say, hey, that data doesn't tell me all the information. I'm going to see the ultrasonic test that Eric Flynn from Los Alamos did for me, and I can see again on the surface, hide it, deploy, change it back and forth. And this is a hands-free ability to get an augmented assessment of the infrastructure. So imagine very tall bridges or other difficult to reach, hands-free information display in front of me, and I can look this across time when I can see who did the inspection and the kind of data that was there. I will pass it back to David, and we can talk about cracks.
So next what I'm going to show you is an example of how we can imagine this helping inspectors collect data and document data. So going forward, you know, the 50-year design life for structures is kind of questionable. It's likely that we're going to need to go to 100 to 100 plus year design lives. So you don't want ambiguous notes and small numbers of measurements documenting what's going on with your structures. So with these devices, you can see here we're even starting to get the 3D mesh that these can measure for the structure. So you could potentially get high resolution data just on the fly instead of just using a tape measure. You'd also, you think about it, over hundreds of years even culture and language change. So you're going to want really unambiguous measurements. So here's an example of how you do that. So first we start off by telling which operator we are. So I'm David. So hopefully it knows that I'm me now. So now what we do, I go and I do my inspection and I find myself a crack. And so I want to document that crack. And so, let's see, I indicate that I've discovered a crack. And I kind of put my marker there. And then I go ahead and maybe document that crack by measuring it. And so that should be pretty well documented at this point in time. So now, let's say a year goes by later, and now I'm Fernando. And so now I'm Fernando. Fernando comes over here. He's like, oh, I found the crack again. David told me I need to check that out. So he puts his marker down that he's going to check the crack out. And he makes a measurement. So now the crack is grown, and so he's able to really unambiguously document what that crack did. And you can imagine on and on, different inspectors throughout time can have really good notes and dictation and really high quality models of what's going on with that structural inspection. As I mentioned, we can capture 3D data. We've started to integrate this with things like thermal imagers, so you could potentially do flash or various thermography type techniques. So there's a lot that could be done with these going forward. So that's everything we have. Thank you.
Thank you.